In galaxies, the hundreds of billions of stars are not scattered randomly in space. They follow a path that is subtly and invisibly controlled by the central black hole, which acts as a kind of blueprint for the entire galaxy. In the energy filament theory, the black hole is not simply the center of the galaxy as traditionally thought, but rather it serves as the ultimate tension reference point for the entire structure. The black hole influences where the galaxy's space is tightly compressed, where it is more relaxed, where objects move quickly, and where they slow down. The stars, in turn, naturally align themselves along this tension map, just as rivers follow the natural contours of the land. The entire galaxy's structure is shaped by the invisible forces emanating from the black hole's influence. Much like a city's roads follow the structures laid out by its central subway station. To make this concept more understandable, imagine a massive city with an interconnected subway system. The central subway station doesn't necessarily suck people in directly, but it silently dictates the layout of the entire city's roads, traffic flows, and routes, creating a grid of movement. Similarly, a galaxy's structure isn't random. It is organized by the black hole's gravitational and energy forces that subtly guide everything. The galaxy's stars follow this guided distribution of energy and gravitational tension, ensuring a harmonious structure governed by the black hole's invisible influence. According to the energy filament theory, the black hole shapes and controls the galaxy through three major factors. First, the establishment of the tension center. The space surrounding the black hole is highly stretched, and particles move more slowly due to this intense compression. As you move farther from the black hole, the tension lessens, and the speed of particle movement increases. This tension gradient naturally aligns the orbits of the stars within the galaxy, much like how roads in a city naturally curve around a central subway station. The stars' orbits are shaped by the subtle but powerful tension forces at work within the black hole's reach. Second, the jets serve as sculpting tools. The black hole's poles shoot out powerful jets that expel gas, compressing it into massive shells and pushing out areas of empty space. This can be compared to carving out large wind tunnels within the galaxy. These cavities and shells serve to direct new cycles of star formation, ensuring that the large-scale structure of the galaxy and the direction of the black hole's jets remain in harmony. This sculpting process is fundamental to the galaxy's development, as it continually reshapes and guides the galaxy's spatial arrangement. Third, the black hole's rhythm spreads throughout the galaxy. The rolling of the black hole's core, the rhythmic pushing of the tension waves by the piston layer, and the pulsing of the pores at the outer critical boundary. These tension patterns extend outward, influencing the entire galaxy. As these patterns propagate, they synchronize the motions of gas clouds, star clusters, and even the galaxy's spiral arms, which began to move in a coordinated, almost choreographed way. This synchronized movement gives the galaxy a sense of unity and order, despite appearing chaotic or random at first glance. In this picture, the black hole is not just a void at the center of the galaxy. It is the heart, the commanding force, and the reference point for the entire galaxy. The jets carve the structure, the tension governs the stars' orbits, and the black hole's rhythm drives the changes and movements across the galaxy. The grand order of the galaxy, then, is not random but rather in perfect harmony with the black hole's invisible yet powerful influence. Though a galaxy may seem chaotic or unpredictable, it is actually deeply governed by the invisible tension forces of the black hole, operating to a rhythm that can be traced back to the heart of the galaxy itself. Everything in the galaxy is moving in sync with this rhythm, even though the movement may appear random to the untrained eye. In the next episode, we'll explore why stars, as they approach the end of their lives, they have no resistance when they encounter the immense power of a black hole. Tap follow, share it on New Physics, Clear Universe.